Welcome to qnawire.
Hi, so over here we're going to have the following Diels-Alder reactions with benzene, which are going to be rare as it is mentioned. But in this case, do not feel intimidated by the fact that we have a different DN. In this case, what we're going to do is proceed with our labeling as follows, as you would do with any Diels-Alder reaction. And just remember that the bonds that are going to be formed are going to be, actually let me put it on the right. The bonds formed are going to be in between carbon 1 and carbon 6. In between carbon 2 and carbon 3, we will have an extra pi bond. And in between carbon 4 and carbon 5, we're going to have an extra bond. And the ones that are being broken are going to be the pi bonds in between carbon 1 and carbon 2, carbon 3 and carbon 4, and in between carbon 5 and carbon 6, also the pi bond. And recall that always the arrow pushing mechanism is going to stay the same. So in this case, the pair of electrons coming from the DNophile are going to attack on carbon 1. The pair of electrons of the double bond goes towards the bond between carbon 2 and carbon 3. And the last pair of electrons is going to go to close the cycle by generating a bond in between carbon 4 and carbon 5. In this case, we're going to use the auxiliary labeling of these extra two carbon atoms, 7 and 8, just to be able to write down the final structure when we're done. So with this, what we're going to do is proceed with our usual cyclohexane here, our ring. I'm going to make it a little bit bigger just because we have the inconvenience to have this extra two carbon atoms that we need to account for. And we're going to use the same labeling as always. 1, 2, 3, 4, 5, and 6. In this case, in between carbon 2 and carbon 3, we have the extra double bond that was generated. And in this case, in between carbon 5 and 6, we had a triple bond. Thus, we're going to end up with a double bond. Now we can get rid of these two labels and complete with the cyano group on each of them accordingly. And finally, we just need to take into account the 7 and 8 that we have. In order to do so, we're going to use the space in between these carbon atoms. Actually, let me make it a little bit as follows. Tuk, tuk. And this would be our carbons 7 and 8. Let's label them here, 7 and 8. And with that, it would be all. That would be our final structure. Let me just clean up the molecule a little bit just for you to be able to copy it properly. Such. Yeah, looks way better. And now we're going to do the same with the second reaction. The pattern is going to be completely identical, and actually you're going to realize that we're going to get essentially the same structure, just with the change of the CF3 instead of the CN in both of the cases. So let's go ahead, write down our bonds. Over here, double bond, the one corresponding to carbon 7 and 8. In between 5 and 6, we have a double bond, and the substituents are going to be CF3 on both of them. And this would be both of the products that we require. Again, let's just clean up the structure a little bit so that we are done. And with that, it would be all. Thank you very much and have a good one.